economy. And those that you are doing in this typology of produce projects is a demonstration that it's possible to do things that the society see as a success and products that will be in the market, improving the sustainability of the packaging, and not only the food sector, but also in the cosmetics. So, as Berta said, Milena, if you want to interrupt me in any moment to introduce or to include something else, but in the meantime, I would like to introduce this first session of presentation with 4 summaries of the main points of this transition from the linear to the circular economy. The first of them is the project introduction and the eco-design of this Citruspack bio bottle that will be done by the Dr. Carolina Peñalba from AITIIP. The second presentation will be done by the Dr. Maricruz Arcas and will be focused on how to revalorize the citrus pulps and peels during the juice production. The third presentation will be done by the Dr. Vesna Sepik and collaboration with Peter Fats, and it's also a way to valorize other waste from the citrus powder, and this one for the production of biojar in order to produce cosmetic packaging applications. And the final presentation will be done by Georgios Tsatsos, and will be at the replication of these applications from the packaging sector for the food to the cosmetic application. So let's move forward for the first presentation that will be done by my colleague, the Dr. Carolina Peñalba. She's PhD in food science and technology. Is also the packaging and the agri-food sector responsible here in AITIIP. Her work from more than 7 years has been based on the advancement of knowledge on bio-based and compostable materials. Also, the integration of new technologies or the effort of incorporating active substances in the development of plastic food application. She has also actively participated in the management and execution of competitive and not competitive R&D projects. She has coordinated the success Life Multi-Bio-Salt project with really good application for the agri-food sector in the mulching applications, and also she's currently coordinating the project Life Citruspack. In addition, she has worked as a expert project evaluator for Bio-Based Industries Consortium. She's a member of the working group of the IP Agri of the European Commission, reducing the plastic footprint of agriculture, and is a member of the advisory board of Horizon 2020 project in Green. So, Carolina, please, the floor is yours.
Good morning, everybody. It is my pleasure to be here with you all in our final conference. Today, I will be presenting the project introduction and the Citruspack bio bottle production. Here you have the contents of my presentation. First of all, I would like to present briefly our entity, AITIIP Technological Center. AITIIP Technological Center is based in Zaragoza, Spain. We offer to our clients and partners all our capacities and knowledge in different plastic transformation technologies and final products. As you can see in the pictures, our facilities of almost 17,000 square meters are very close to industry, particularly at the injection line. And we also offer other different plastic transformation technologies, such as blow molding, extrusion, casting, thermoforming, 3D printing, at pilot and semi-industrial level. We are always improving. Each year, 1.5 million euros are invested in new equipment. At AITIIP, we are working almost 100 people, and the R&D department is an interdisciplinary team composed by chemists, engineers, food technologists, and social profiles to help companies to overcome their present and future technological challenges in the frame of sustainability by applying commitment and the latest technology, innovation, and knowledge. Currently, we are participating in more than 25 European projects in the frame of circular economy and Industry 4.0. Along the final conference, our partners will explain their main role along these years. But now, let me first introduce a little bit the project to you. I will start with a brief introduction on the environmental problem and the business opportunity that the project approaches. Only in Spain, citrus production is around 6 million tons per year. Many of these fruits are brought into juice production, and during this production, huge amounts of citrus residues are generated. These residues are usually discarded as feed, but its rapid fermentation turns it into an environmental problem. On another hand, plastic packaging has become an integral part of our daily lives. Plastic packaging represents almost 39% of the European plastics market. Packaging is by far the largest contributor to plastic waste, with a 63%, because packaging items such as films, bags, bottles are conceived by a large part of the end users as disposable products with a very short lifetime. Consumers are interested in using less contaminant solutions for packaging, and the European Commission has listened to the consumers and has launched recently the first European plastic strategy. Citruspack aims to address both problems. First, the inadequate citrus waste management after the use of the fruits as raw material for juice production, and to reduce plastic packaging waste by using biodegradable plastics reinforced with citrus peel wastes. During Citruspack project, we extract from the peel and pulp wastes additives to be used on one hand as reinforced additive for bioplastic packaging, and on the other hand, additives for cosmetic products. We have two demonstrators as plastic packaging, a juice bottle and a cosmetic jar. We envisage at least two demonstrators of the cosmetic products developed with the additives extracted from the Citruspack project. To accomplish with the project activities, Citruspack is composed by 7 partners from 5 different European countries. The project is coordinated by AITIIP, and participating is AMC, a multinational juice producer, OLVETIA, a cosmetic company, and a Spanish retailer, Eroski. Participating in technical issues together with AITIIP is TECOS, a Slovenian technology center, and OWS to perform LCA as well as biodegradation tests. Finally, a cluster for dissemination and replication of the project results, Plastipolis. The project has a duration of 42 months and a budget of 1.7 million euros. Now I'm going to explain the technical activities carried out in the project. The first action has been produced by AMC Innova. The development of the Citruspack products started with 3 flows coming from the juice production: citrus peel, citrus bagasse, and a pure emulsion essential oil. AMC pilot plant has optimized the method, incorporating an extraction, blending, and drying steps in order to make the process more efficient from the point of view of the application and obtain several byproducts in a cascading approach. After different trials and combinations, a product called orange fruit powder and 3 essential oils has been obtained. Continuing with the technical activities carried out in the project, I will explain now the first revalorization line, the production of bioplastic products. The powder developed by AMC is mixed with selected biopolymer grades, as well as other additives to improve the final performance of the material in a conventional extrusion compounding process. The materials produced have been characterized by flow analysis and by mechanical, tensile, and flexural tests. Also, the thermal properties, such as the heat distortion temperature and the determination of the VCAT softening point, have been studied, as well as the thermal desorption and temperature dependence test using differential scanning calorimetry and thermogravimetric analysis. Finally, the quality of the dispersion have been studied through a morphological evaluation using scanning electron microscopy. For the production of the cosmetic products, we have used citrus essential oils as perfume and orange fruit powder with antioxidant and hydration properties in 3 different products: face scrub, eye serum, and face mask in different percentages. To validate its performance, we have studied the stability of each formulation by means of an accelerated stability test with an examination of light microscopy. Different parameters such as viscosity, pH, particle size, aroma, and color have been evaluated. The best formulas have been carried out in a pilot demonstration test, evaluating their behavior in mixing, homogenization, and filling conditions at an industrial level. Different material formulations have been developed in order to obtain 2 demonstrator products. One of them is the juice bottle with its cap. To obtain the prototypes, first the cut design of the bottle and the cap, as well as their molds, were produced. The design of the bottle and the cap were validated by 3D printing. Finally, the mold for the production of the bottle by blown extrusion molding and the mold for the production of the cap by injection molding were manufactured. The second demonstrator product is the cosmetic jar. In this case, we followed the same scheme. First, the product prototypes and the molds were designed. The designs were validated by 3D printing. After the validation, the molds were manufactured. In this case, as you can see, we have 3 different molds. One is for the cap, one is for the jar, and the third one for the inner insert. On another hand, one of the objectives of the project was to characterize the materials according to the compostability certification. To do this, OWS determined on the final plastic products the concentration of heavy metals, fluorine, and volatile solids. Also, the degree of disintegration of plastic materials was determined. Finally, the quality of compost, including the toxicity tests in plants and the study of biodegradation under controlled composting conditions, were performed. The biobottle was validated by agency with the use that generates the wastes in the project, and the cosmetic jar was validated with the cosmetic products produced with the natural additives obtained during the project. Finally, Eroski carried out an acceptance test with consumers, and Plastipolis has been leading the dissemination activities, assuring a good replicability and transferability of the project results. Now I would like to present AITIIP's main role during the project. Different cooling and drying techniques have been tested. Has been processed for the elaboration of different mixtures used to obtain the bio bottles and the cosmetic bio jars. In addition to this, nanoclays and celluloids were used for odor absorption in the injection samples, and an impact modifier was needed for the bottle production. Finally, in order to assess the acceptability of consumers, several color samples were produced. Different cooling and drying techniques have been tested to optimize the quality of the final pellets obtained. A key point has been the introduction of natural additives to help lowering the process temperature, in order to reduce the caramelization of residual sugars in the orange fiber powder. Materials produced along the project were characterized in their tensile and flexural properties. Mechanical tests were performed under ambient conditions, and at least 5 specimens per material were tested according to the standard methodology. In general, the values of the tensile modules obtained for the resulting materials with addition of the citrus wastes are not different for bottles and for jar samples. The values obtained for the tensile strength for the juice bottles and the cosmetic jars decrease with the addition of the citrus powder and the necessary additives. The elongation of rake was decreased with the addition of fibers for both applications. This is due to the fact that the compounded materials become more brittle with the addition of the citrus fillers and additives. The values of the flexural modules obtained for the resulting compounded materials for juice bottles and cosmetic jars were higher than those for plain PLA, and these values were higher with the higher amount of citrus waste powder. The impact of the fiber additivation on the thermal characteristics of the compostable compounds have been evaluated through thermogravimetric analysis. The temperature corresponding to the onset of the composition is essential for evaluating the thermal stability of the samples and is shown in this table. The PLA mixed with the fibers have lower onset temperature than those of plain PLA samples. The results shows that the sample with higher concentration of citrus waste powder have less thermal stability. The maximum temperature at which maximum mass loss rate occurs is increased with the concentration of citrus waste powder, and so is the mineral content and the non-volatile fraction of the samples. The results of the final residue are consistent with the amount of citrus waste powder added to the samples. The higher is the citrus waste powder, the higher is the percentage of final residue. Finally, the quality of the dispersion has been studied through a morphological evaluation using scanning electron microscopy. The interface in any fiber matrix composite system is responsible for transmitting the load stress from polymer to the fibers. This stress transfer efficiency largely depends on the fiber matrix interface and the mechanical properties of fibers and polymers. The same images show the dispersion and affinity between the citrus waste powder and each of the biopolymer matrices used. The natural composition of the citrus waste powder shows a clear effect in the interaction mode with the biopolymer. On the fracture surface, we can observe some round fibers pull out from the matrix, but most of them are still tightly linked to the matrix. The organophilic materials are not compatible with the hydrophobic organic matrices, and hence diffusion of the polymer chains around this type of molecules is not possible. These small rounded particles are found in both cases. To the left, we can see an EXD analysis image of the sample with a 15% of citrus waste powder plus PLA, and it shows the presence of aluminum silicates and calcium and sodium chlorides, which shows some other presence that interferes with the matrix. AITIIP was also in charge of developing the bio-based bottle. To do this, as explained before, the design of the bottle and the molds were needed. First, the requirements of the end-user AMC and Eroski were compiled. Different bottle designs were made and the most voted at AMC was selected. The volume and cap dimensions were also decided. The design of the final bottle and cap were validated by 3D printing. Once the designs of the bottle and the cap were validated by 3D printing, the mold for the production of the bottle by blown extrusion molding and the mold for the production of the cap by injection molding were manufactured at AITIIP. On the right, you can see the mold for the production of the cap functioning. Finally, with the molds and the materials produced, we have obtained the Citruspack juice bottle. Along the project, different models have been produced, from monolayer to a 3-layered bottle. In all cases, the materials have to be dried in the humidifier or in oven. This is very important. As you can see in the table below, if we use the Citruspack materials, we have to decrease the temperature and adjust the speed or the cycle time per bottle. The bottles and the caps produced at AITIIP were sent to OWS for the compostability assessment, to Eroski for the consumer acceptance, and finally to AMC Innova for the validation with the use and shelf-life assessments. In this last slide, I would like to show you the evolution in the development of the Citruspack bio bottle. We have finally achieved a 250 ml bottle with a 5% citrus powder PLA, with good thermal stability, adequate for flash pasteurization, and validated for industrial compostability at a competitive price compared with other biodegradable materials. Thank you so much for your attention. I hope you have enjoyed the presentation. I will be available for any questions you may have at the questions and answers section, and also you have here my contact details. Thank you again, and enjoy the rest of the conference. Thank you.
Okay, thank you, Carolina. They are all, as you can see, we have had some problems with the internet connection. We think that we have already solved. So anyway, all these presentations will be available for you after the conference. So sorry for these problems. And now go to the second presentation in which the Dr. Mari Cruz Arcas will demonstrate how it's possible to increase the sustainability of the juice production by means of revalorizing citrus pulps and peels. Mari Cruz Arcas is graduate in biologic science and PhD in biochemistry by Murcia University. She is specialized in natural bioactive phytochemicals. She joins AMC Natural Drinks 20 years ago, taking part of the production team with an acquired experience in Mediterranean fruits and the squeezing process using the whole fruit for build a sustainable industry. After this time, she is passionate of fruit and veg, bioactive polyphenols with health benefits. In 2013, when AMC Innova was created, R&D division of AMC Natural Drinks, she took the responsibility of science director, and today is in this area where she continues contributed with her expertise to the team through managing research projects. She is facing new challenges every day with the main goal to carry out to the market new products to improve the life of the consumers, raising the competitive advantage of her customers. So thank you, Mari Cruz, to be part of this project, and the floor is yours.
My name is Mari Cruz Arcas. I'm the scientific director of AMC Innova, a company below AMC Natural Drinks. And today I'm going to present what has been our result in the Citruspack project. First of all, I would like to introduce our company, the two holdings, Forest AMC Natural Drinks, and the group is the third company of international sales in Spain. Also, Natural Drinks is present all over Europe in the main retailers, with our main business, our main product that is chilled juices, chilled that are keeping in refrigeration during all the supply chain, very high quality premium juices, and in this sector, in this category, our market share is around 50%, but if we filter to innovation, we have a market share of around 70%. AMC Natural Drink is vertically integrated. That means that we control all the supply chain. We start with the fruit. Also, we have our squeezing unit, Fruit Chain Natural, very important unit here in this project. Also, we have our bottling unit to fill our own use, and also we have our own R&D company called AMC Innova. AMC Innova is the company which gives service of R&D and quality to all the holding. We say always that we are a consumer-centric division. That means that we start our research in the consumer. We continue about the new product development, new technologies, in order to have at the end the best product in the market for consumer. The bottling units that we have are seated in Europe, in Holland, Spain, Portugal, and Italy, and we are certified by the most important organisms to verify the quality. The subdivision of squeezing is Fruit Chain Natural. This is a very important division, very important unit, business unit in this project, because we receive the fruit, we obtain the juices, the concentrates, the puree, but we also have in this unit a lot of possibilities with the waste, because we take the waste, we do all the research necessary to understand and characterize the product in order to develop ingredients with added value, and in order to reduce the waste that goes to the landfill, in order to keep our commitment in sustainability. In this supply chain control, as I mentioned before, we have the division of fresh, that we have our breeding unit, that we make all the research in order to build and to develop new varieties, and also we control all the plantation, and we control all the quality during the growing. Coming back to AITIIP Innova, I would like to say how we are working this unit. Of course, we have an open innovation model, and this is why we are here, because we try to collaborate with different companies, different universities, different technical center, and working like that, we have developed 25 different research projects funded by the European Commission and also by the Spanish government. And in the framework of this project, we have developed pattern, ingredient, functional ingredient, and also we have run different clinical studies to prove the efficacy of the functional ingredient that we have developed. And finally, the fruit of this way of working, it was recognized 2 years ago when the King of Spain gave to us or delivered to us the National Innovation Award. Now you are going to meet our team, our Citruspack team. We have Damiano, that is expert in the supply chain and also in sustainability. Belén is expert in control quality. Sergio is the expert in project management. Myself, Maricruz. And of course, we have also Mercedes Ramon, that is she is the expert in finance, in financial. Yeah, in this slide you can see what is our role in this project, why we are here, and why one day the consortium call us in order to offer to take part of this project. First, we are a squeezer. That means that we can have all the raw material to develop the fibers, the byproduct, in order to apply them in the bio bottle, in the bio jar, and also in the cosmetic. And after that, once we have the packaging, the bio jar, and the bottle, we can close the circle, because applying the filling machine using the bottle, we can have all the validation of the packaging. We can run this validation, and also we can certify if this packaging can be available to commercialize the product. This slide you can see how we receive the main byproduct, the main waste in our plants. When we squeeze the citrus, the orange, the lemon, and the mandarin, we have citrus peel, also citrus bagasse, and also we have that we call the for emulsion essential oil, that is a water with oil. And depending how we treat this byproduct, we can have, if we dry direct, we can have powder, we can do different process in order to improve the quality, to extract the bioactive compound, to extract the fiber. And in this case, we can have comminute, citrus peel extract. Also, if we centrifugate the pour emulsion, we can have the rich emulsion, that is the pure essential oil. And after that, we can again to dry these ingredients to have another powder format. Now I'm going to start with the final result of the project. Once we establish all the process, all the processing, all the flow chart for the byproduct extraction, we start to work with the consortium, with the member of the consortium. In this case, with AITIIP, TECOS, and in cosmetic, in order to select the most relevant and the ingredient that work better in their application. So for cosmetic clean, we select the orange comminute and the lemon essential oil. The main parameter that we took into account, it was for orange comminute, it was high in spiridine, vitamin C, insoluble and insoluble ratio of fiber was the perfect one, the quantity of natural essential oil, the low content of sugar. And the lemon essential oil, it was chosen because it was the citrus essential oil with the high content in aldehydes. The same way, we work with AITIIP and TECOS, and we establish the parameter that we need for the level of the bio bottle and the bio jar. And the first point it was that the byproduct to be applied in this packaging must be in powder format without water. So we develop powder for this application. And finally, taking into account the variability of the fruit, we choose one byproduct that is stable during all the season, that is the citrus fruit powder. We choose also because we can have enough quantity of volume, because technically we can repeat the process without problem. The process was very well established, and also the price is affordable, and the fiber content is the right one for this application. After we choose we did the sorting with the raw material, with the byproduct. We came to the last stage of the project, doing the pasteurization treatment that we need to apply in the use using the bottle that has been developed in the Citruspack project. The processing that we applied to this bottle and to the uses, it was the cold and the hot pasteurization. The cold pasteurization, it was by HPP, high pressure, and we choose for this trial apple juice. And this apple juice was treated by the process that we know is a safe process and is worked properly for the use. That is, we apply 6,000 bars during 2 minutes, and now you can see the result in the picture. Only 3 bottles of the total was okay, the other ones were broken. That means that the next step should be to improve the traceability and the elasticity of the bottle, doing a revision of the additives, doing revision of the thickness of the bottle, and now doing a proper adjustment between the cap and the neck of the bottle. And the second treatment, it was the flash pasteurization, that we say hot pasteurization. We make it this pasteurization in our pilot plant. We fill the bottle, and now we have started a life study. We fill the bottle with in this flash pasteurization. We fill the bottle with orange juice, and here you can see that we are running now the cell life study. It will be running till 120 days, more or less. But the good news, that the good result that we have till today, till 2 weeks, is that the juice is okay. The juice exactly have after 2 weeks exactly the same quality, that we have the first day. You can see the result in the spider diagram. That you can see some slightly different, but it's nothing significant. So the quality is okay till today, and we will have all the final conclusion when we finish the cell life study. And here you have listened our results, but before finish, I would like to thank to the European Commission the opportunity to be in this project. So thanks. Again, also I would like to thank to the consortium, because it has been a very challenging 3 years, and I want to thanks to everybody. So thanks for your attention. Good morning. My name.
Thank you very much, Maricruz. To show to all of us how it's possible to increase the sustainability of the food production processes. And the third presentation is also focused in demonstrating how it's possible to improve even more this sustainability by means of using citrus waste powder to produce bioyard that will be validated in packaging applications. These presentations will be carried out by Vesna Sepik and Peter Fox from TECOS. Vesna is accomplished her bachelor science thesis at the Biotechnical Faculty of University in Ljubljana in 2010. In 2011, she joined the Research and Development Department on Advanced Plastic Materials and at TECOS as a research associate. And in 2015, she received her PhD in biosciences at the University of Ljubljana. She's currently on the position of youth project manager at TECOS, and she's working as a coordinator or panel member on several applied research and development projects for national and international funding schemes. She is an author of several scientific and conference articles and has written over 32 professional articles and 7 elaborated studies. Peter, that is currently developing his research in the laboratory for applicative materials at TECOS. So, guys, the floor is yours.
very warm and healthy good morning. We are offering also rapid prototyping and mid-scale serial production of injected parts, and we are offering any kind of services with 3D scanning and reverse engineering. So regarding the technological infrastructure, we can divide it into 4 main pillars. So testing and prototype productions. So we own the injection molding machines. So we have the capabilities to produce, actually to manage or to cover all the projects from the initial idea to the final prototypes. We also have the equipment for testing of polymer or metal materials, and we also have special units for composite or thermosets processing. We also own really a rich package, I would say, of the software licenses for simulations. So for the processing of injection molding technology as mold flow, for the structural analysis of final parts with Abacus, for the automotive products, CATIA. We also have Siemens for the 3D CAD modeling. Then we have the 3D scanner, the optical scanner instrument, ATOS, and we are performing the measurements of really large objects such as planes, trains, or cars from the very small objects on site. And we are compiling all the inspection of and the final dimensions of the inspected product, and we are providing all the necessary services regarding the reverse engineering. Then we also have the 3D printing machines for plastic and also for metal. So we have the capabilities to produce metal printed objects, products, prototypes, and also plastic first visualized, I would say, products from the very core idea. So this can be done very, very fastly with this kind of 3D printing technology. Then I would now skip to the main part of my talk today. So to briefly introduce how our role was adjusted, I would say, in the name of the Citruspack project. So what we did and what we have achieved through the last 3 years, 3 years and a half, I would say, of research during the Live Citruspack program. So our responsibilities and assignments, I would say that we were actually divided for the action of the production and validation of cosmetic jar packaging. So first of all, we were responsible for a correct product design. Of course, we have been listening to the end user, to their requirements and their desires about the final product's aesthetical appearance and also all the functionalities that came along. Then we construct and manufacture the prototype molds, the prototype injection molds, and we perform several packages of numerical simulations and processing optimization through design of experiment. And then we also perform some trials with odor absorbers, so to minimize the maybe unpleasant smell of the final demonstrators of the final cosmetic jars. And we also perform some trials with different kind of colorants, so to offer to be able to offer different kind of solutions for the final packaging products in the name of colored variants. Okay, and then we of course validated this packaging, and we also performed together with another partner that will explain, I think, a little bit later on about the biodegradability testing of these products that are made from biodegradable materials. Then at the end, we can now gladly offer a serial production of cosmetic packaging demonstrators, and I will show at the very end our key contact points and our summarize actually about our solutions, from which you can decide if this kind of packaging could be interested also for your products or also for your business or not. So with the very first slide, I am opening the product design. So we have performed some 3D modeling, or I would say computer-aided design, that allows, of course, to build a realistic computer models of parts and assemblies. So we designed 3 assembled demonstrator, I would say, from outer housing, and then from the inner insert and from the lid. After having the core product design in our mind, or I would say on our computer, then we use it for the rapid production of the 3D printed prototypes. So for the these CAD models were used for the construction designs of the injection molds afterward, and of course to run the complex simulation analysis. So on the below pictures you can see the 3D printed jars with the lid, but of course, as I was saying on my previous slide, we have been consulting about this product design with end user. In this case, it was OLVETIA, the producers of natural creams and natural cosmetic products, regarding the aesthetic visualization, regarding the milliliters of the volume of the jar, about the final requirements, and of course adjustments that were needed for the automated filling and final assembly line. So these are the prototype injection molds that were fabricated during Citruspack project. So for the upper cover, we have been constructed, I would say, hydraulically opening of the screw inside the lid, and this is not a very simple mold, I would say, but yes, at final we managed to fabricate it, to assemble it, and to run it for the serial production. Then we have been building the injection mold for the outer case and the injection mold for the smaller insert, where the dosing of the cream is actually inserted, or other cosmetic products. The volume of the insert is 50 milliliters in this case. Then we, after having the molds ready for the operation, we need to adjust the processing parameters on the injection molding machine, and we did it with the design of experiment according to the statistical method of the Gucci. So we have select 3 level parameters and 3 variables, so injection speed, mold temperature, and melt temperature, and we perform 9 factorial combinations of tests. And through this statistical analysis, we managed to outsource the optimal processing parameters. And the optimal processing parameters you can see listed in the table here below on your right. And we found that through the Gucci design of experiment, we were able to identify the influential factors in injection molding processing, and to state their very best values for the production of high quality and robust products. And the most influential factors were melt temperature and injection speed, while mold temperature had a really not very important impact on the whole process. Then we ran some numerical simulations and optical 3D measurements on the final parts. So with the advanced injection molding simulations, we were able to predict actually the filling time, the injection pressures, the clamping force, the shear rates, any kind of deflections that could be crucial in our process. And also we managed to time frame the injection time profile, and also we managed to predict any kind of shrinkages and product warpages. And by defining that, we could eliminate those, or at least minimize those with the proper set of parameters. And then, of course, prior to running the numerical simulations, we need to characterize the final material, and we do the mold flow database inventory. So we measured the shear viscosity, we measured the thermal conductivity, the specific heat, the mold validation, and PVT properties. And then at the final, we were able to verify the processing, so by adjusting the parameters for minimizing any kind of air traps, bed lines, and also sink marks. At the very end, we collect the injected parts and we measure them, so to really be sure that dimensions and tolerances are correct for our injected parts. And we also try different kind of material formulations, I would say, and those were mainly dictated, I would say, or transferred from AITIIP, which has really vast background knowledge on the proper development of material for the specific processing technology. So different material formulations were developed depending on the citrus powder contents, addition of various absorbents, even addition of plasticizers and nanofillers to improve the processability. So testing trials with different temperature profiles were conducted on our injection molding machine, on our new prototype molds. So temperature were varied in between 155 up to 170 degrees Celsius. And then the odor of the produced cosmetic packaging was also detected to be very least intense for the injected parts that are processed at around 160 degrees Celsius up to 165. So the visual appearance of biojars was also mainly governed by the composition of the material or by the citrus waste powder content. So we can state here that formulations with 50% of citrus waste worked very well on injection molding processing, and also with the 20% of citrus waste powder, but with the addition of higher content, so amount of 30% of waste powder inside the final formulation. It was found to be really challenging in the processing, because the final aesthetic appearance of the cosmetic jars was not really satisfied. You can see on. Then yes, like I was saying, because mixing with citrus waste powder and the polylactic acid, it produces a kind of combination that has a special odor, I would say, or a special smell. So perhaps this is not the most desirable functionality in the cosmetic sector. So we try to reduce the smell of the final packaging jars with some addition of the absorbers, and we select zeolites, which are natural aluminosilicate minerals that are used as odor control or removal additives in formulations such as thermoplastics, duroplastics, fibers, films, coatings, inks, paints, and so on. So by direct activation of zeolite powder during the injection molding of citrus PLA material, we aim to minimize the odor of cosmetic jars, but we achieved only a marginal improvement at the expense of the progressively developed display marks. or I would say silver streaks on the surface of the final product. Then on the other hand, we try to offer also colored version of Citruspack biojars. So we produce different series of citrus peel and colored version with natural shades of colorants. So yellow, brown, orange are its picture. And we add around 1.2% of the colorants inside the master batches. And those were added actually to the final citrus peel material composition, and we managed to produce really nice shades of the inserts and also outer case. So you can imagine here different kind of combinations for your final packaging products. And as I was saying at the very beginning, we also validate our packaging according to the biodegradability properties and also to the compatibility with the cosmetic products inside. We also tested the thermostability performances of the final packaging. So we measured the pickle softening temperature. It was around 52 degrees Celsius. And also about heat deflection temperature, which is indicated how stable this packaging is in the raised temperature operation. So 45 degrees Celsius, it seems to be an upper limit bound for this kind of packaging. We managed to produce Citruspack cosmetic biojars. The best formulations was with 20% addition of citrus powder inside. The thermostability of this packaging jars is in between 45 to 50 degrees Celsius. For the water-based cosmetic products, this kind of packaging is not recommended, but for oil-based cosmetic product, it's totally approved. Industrial compostability was found to be completed in 12 weeks, the entire set, so all three compartments together. And we are offering you different kind of colored versions of these packaging jars, and the sale price was also determined, and it comes around 1.6, 1.7 euro per set. And here at last, I would like to thank you for your kind attention and patience. Here again, my name is Vesna Žipić-Bukataj. I am head of the laboratory for applicative materials in TECOS, and here below you can find my key contact data, so my email, my telephone, and even my address, in case you would have some additional questions or some additional inquiries regarding the biojars, the Citruspack biodegradable cosmetic packagings. I am here for you.
Thank you, Vesna. Before go to the last presentation, we would like to open the floor to our project advisor, Milena Sumanova. So, Milena, the floor is yours.
Hello, everybody. I'm first of all, I apologize for the earlier technical issues. I hope you can hear me clearly now. Could you just confirm that?
Yes, yes. Yes, Milena, we can hear you.
Okay, fantastic. Sorry for the earlier disruption. I'm very glad to be with you and listen. I have a chance to listen to some of the previous presentations and see that things have let's say finalized and evolved in a good direction, and it's really I'm really impressed to see all these results. Also, not only but also in the context of the still ongoing and quite challenging COVID situation, and many of our projects being delayed, and many of our projects facing also financial difficulties. So this is in particular in this context, this is really good news, and I really congratulate you that you managed to pull this through despite all the challenges of the past year. And I have been very glad to follow this project from different angles, from different perspective also through the lens of our support or the support through the close to market experts, which has been also interesting to follow. So yeah, so overall, once again, congratulations. Very pleased to learn about your progress and you know, attaining the objectives and results. I mean, we are we can clearly see that it is feasible to that you have managed to basically confirm this feasibility of the revalorization of the citrus wastes for the bio and for the compostable packaging production. So this is really yeah, this is really good that we can conclude that it could be introduced to the organic fraction container. And also the replication that you have been working on within the duration of the project, that has also been very appreciated from our side, because you have also focused on demonstration of the feasibility of other products, which would be based on citrus waste. So yeah, the pots or the water bottles or yogurt tubs, etc., which represent a big part of normal standard plastic waste normally. So this is also something to really emphasize and highlight. And also it seems also from what I understand from the commercial perspective, that it's there is also the feasibility to commercialize of the bio bottle and bio jar products. And if I understood correctly, correct me if I'm wrong, you are also starting the possibility of commercializing 3-layer bottle. Since I understand, yeah, because of the impossibility of the product not being allowed to be in direct contact with food. So what I also appreciated was that, and I think you should really sell this much stronger, or you should sell this strong in your final report, is that you managed to provide this comparison in terms of the environmental impact of the project products which you developed, and in comparison with those which are currently used in terms of the plastic packaging. So definitely this updated final assessment should be a prominent part of your final report, and please think of it as a window where you have the possibility to showcase all your results, and in a clear and comprehensive way. So I also understand that in November you have been again in touch with the close to market experts from our team, NIMO team, EY team, with whom you discussed also the commercial prospects, and if I understand, with regard to the market readiness, that you're preparing the business plan, and I understand that you were planning, or you were meant to share it with the expert team, with the C2M team, end of last year or early this year. And it was also interesting that you have identified with the C2M experts the key clusters or the key outcomes of the project, which can be monetized, and which I understand you aim to monetize after the end of the project. So these are the product bottles and the cosmetic jars, as mentioned, the cosmetic products, and also the blends. And there you were mentioning also the spin-off creation, and also the licensing and the raw material. So there is a number of outcomes or outputs which you can introduce into the market, and this is also great. Yeah, it would be very interesting to read more about this in the final report as well. If you could also develop a little bit more on this, what are the next steps, and what under each outcome, what are you planning to do, or how are you planning to implement this commercialization? This could be under most logically under sustainability and part of the report, because this is obviously the biggest value, one of the biggest values of your project, that it is not one of those that it would let's say cease or fade out after the end of the project, but it has a high potential to continue, and it will continue if and I see that you are all dedicated to it, so it's really good. It's a really good news. I'm not sure if yeah, I wanted to also address the from the operational perspective. It would be great if you could also, while you finalize the before the final report, if you could also finalize the checklist completion. We usually send 2 checklists to the close to market checklist, one at the beginning, towards the beginning of the project, and one towards the end of the project. So I'm not sure, could someone confirm that you have received this second checklist, the last one, the final?
Sorry, Milena, this is Carolina speaking. You meant the KPIs checklist?
No, I was talking about now about the close to market checklist. That's the checklist that normally should be mediated to you either through your TMO or through the C2M experts from NEMO. It's a survey to fill in, and it basically is supposed to summarize your market needs and your market readiness.
Yeah, we completed in the past, but we have not received the new one for the final project.
You didn't receive the final checklist, okay, yet? Okay. I will then ask our colleagues from the EY team to send it to you.
Okay, thank you very much.
Because I was informed that it was already shared with you, so there was a misunderstanding.
Okay.
And yes, you rightly also mentioned the KPIs, which is another aspect of the final report. It's just to remind you that the final snapshot in the KPI web tool, that the online web tool that you have the access to, should be filled in a again complete and comprehensive manner, because it has to let's say track or reflect the final stage of the project. So please don't hesitate to include all the relevant information. Under every indicator, you will find a comment box. It's always better and more, let's say, more on the safe side to always fill in these comment boxes in detail, because there you are basically explaining how did you reach the calculation, how did you reach the result, what type of calculation did you use, what type of reasoning did you use, in order to explain the trend, because the final snapshot of the KPI web tool will be reflecting the trend between the beginning of the project and the end of the project, and also the expected trend after the end of the project. So this should have a logical sequence, and it's always useful for us. We always look at the comment boxes when we are reading the indicator web tool. So it's always the more information you include, the faster it goes, the approval evaluation process.
Okay.
Also, regarding the policy, I understand that under the C1 action, you have actually developed, I'm not sure if it's finalized already, but I understand that you developed a deliverable to summarize the recommendations that that basically are supposed to support the development of more effective regulatory policies on various issues. So your project is directly and clearly linked and contributing to the new circular economy action plan and many aspects of it. So it is a very valuable testimonial, and also the potential update or potential feedback to the policymakers with whom we are in a close contact. So what I would like to invite you as a practical suggestion, I don't know what is the stage of the development of the policy recommendations, but even if it's a draft only, and if it's not fully, even if it's not fully finalized, please share it with me, and you can put your external monitoring consultant on copy as well, so she knows, Patricia, now. And please don't hesitate to share it with us, so we can share it for some preliminary comments with the policy unit. And we will present it as a draft, so we will ask them for input and for questions, etc. Yeah, I also wanted to mention the importance of the project dissemination. I mean, yeah, it also helps the project continuation and the replication and the transfer of all the results. So when you will be submitting the final report, it will be great if you could provide the activities, all the activities, basically overview that you did for this purpose, and by all the beneficiaries in the final phase of the project implementation. And there is also the aspect of the dissemination on the regional level, because we want to also look at closer at the like real impact on the population and real impact on the economy as well, on the local economy. So also you can develop on this part, because it's really of interest, and we are really interested in that, and we follow it very attentively. I wanted also to ask you a question. Yes, one more thing. Regarding the communication side, regarding the website, it's a very, I mean, you have a very good and very, let's say, dynamic website, which is quite high quality compared to also average projects. And so we would like you to just make sure that perhaps in a dedicated section you detail really the project achievements in comparison also with those which were expected, and highlight them not in a bureaucratic way, but highlight them in a very clear way, so that also people from external stakeholders who consult your website understand clearly what is the added value of the project, which there are many aspects of that. So look at it as a as a possibility to really showcase your results in a like understandable, like kind of a layman report style way.
Yeah.
And it's more like the project wins rather than a list of actions, but more like real project achievements, and how it can you know, have a direct impact on the environmental, how it brings direct environmental benefits, and how it can have a direct impact on a local, regional, national, or let's say continental or cross continental economy. Once we would be talking about upscaling, for instance. So this would be really valuable to share this with the public. Yeah.
Regarding the layman's report, will be uploaded to the website.
Yeah, perfect.
Maybe today or tomorrow, because we have that in mind, and also to send it to the attendants today.
Yeah, perfect. Also, if you have any videos, if you have any communication products, put them directly there with the links, and make it like a marketing product. The website is really good for also for potential investors or potential interested people interested in your solution. So yeah, so definitely consider that. And I have one more question. Have you been foreseeing or taking any steps regarding the eco-label use?
The eco-label, no, we haven't looked at that possibility.
Okay, because this is something that maybe perhaps would be a question also from the policy unit, whether you are considering that in the future, and because this would...
As in the policy deliverable, yes, we have talked about eco-label, but I was thinking that you were asking during the project for the bottle if we have.
Yes, this is what I meant in the first place. Whether this is foreseen in the future, or whether you are considering it, or
yes,
whether you are discussing that internally.
Yeah, for the future, yes. Internally, we have talked about it, but not taking any steps along the project.
Okay. Well, from my side, this is it. Sorry to go into more details, but I was very glad to use the opportunity to maybe facilitate the preparation of the
Yes,
final
of course.
reporting phase. Yet again, thank you very much for this work and for the let's say, and also very good cooperation within your partnership. I also want to thank to Maria and Patricia, our external monitoring team, and also to our financial advisors, both through the external team, also our internal in EASME, for being for closely following the work and being there to help assist. Mariam is my colleague within EASME, Mariam Gandhi, and she also sends her best regards and congratulations. So glad to have a chance to join you today, and I wish you all the best. And also in the new year, hopefully it's successful and happy and hopefully healthy for everybody.
Thank you very much, Milena. Thank you for being with us today, for your words and suggestions for the final report. We gather all your comments and recommendations. And thank you so much for your support during these years, and all the team, all the people you have mentioned, because we really felt supported by all of you. So thank you very much again, and I keep in touch for the next steps.
Yes, thank you. Thanks everybody, and we look forward to following up in the coming months with the report, and we wish you good luck and all the best to the whole team. Thanks a lot.
Thanks, Milena. So David, maybe we can continue with the next presentation.
Okay, so maybe for the sake of an efficient use of the time, what we can do is to go to the last but not the least presentation and move the questions and answers for the second round, okay? So as Milena said, in these close to market projects, the replication is one of the most important parts, and the next presentation is dealing with this issue. As the replication, a direct replication in the cosmetic application. This presentation will be done by the Dr. Georgios Tsatsos. Sorry, Georgios, for the bad pronunciation of your surname. Georgios is the founder and owner of OLVETIA. He's a chemist with the Master Science in Biotechnology at the University of West of England in Bristol. And he also holds a PhD in the biochemistry for Imperial College. He has been active in formulating cosmetics for the last 15 years. So the floor is yours, Georgios.
We are participating in Citruspack project as end users. We are located in Greece, in Athens, in Koropi. We are manufacturers of cosmetics, food supplements, medical devices, and FMCMBs, food for special medical purposes. We have production and R&D facilities at the same building. We produce creams, lotions, oral care products like toothpaste, makeup, perfumes, and several other forms of cosmetics. In terms of medical device and food supplements, we produce capsules, syrups, blisters, and several other forms. We are certified according to the ISO 9001, to the ISO 22716, which is the GMP for the cosmetics, and the ISO 13485, which is the medical devices GMP. We have also been producing and certified natural certified products by different certifying bodies like AITIIP and TECOS. Natural. In terms of R&D, we have a team that works on both formulating and creating tailor-made formulations. And we also work on the product information file and the regulatory aspects as well for the registration of the product. In the Citruspack, we have worked with in the P32, the cosmetic packaging validation. We were responsible for both producing, evaluating the packaging and producing the cosmetic products and validating them. To evaluate the packaging, we used the packaging provided that was a PLA-based jar, and there were two versions, one which had a transparent or semi-translucent insert, which was from pure PLA, and the other was from PLA plus fibers. And we did some simulants tests to see whether it was compatible with the commonly used ingredients for cosmetics. The result with the simulants that were water-based in all 3 pHs that were used were not positive. So after 4 months at 45, we saw several cracking and disintegration of the jars. Whereas with the oil-based materials, the tests were the jars were fine, and they were suitable for use in the case of oil-based cosmetics. In the sub-action B41, we have used cosmetic materials provided by AMC as cosmetic raw materials. So we used essential oils, extracts, and peeling fractions. The essential oils that we used were orange, lemon, and mandarin. The extras were orange water peel, the orange peel powder, the orange fruit powder, and as peeling fractions were more cuts of fruits or seeds that were larger size, were pomegranate seed powder and pomegranate fruit cuts. The main marketing benefit and claim that the raw materials from the citrus have are the high saccharides concentration that we're giving them moisturization properties, and high content of some flavonoids and phenols that gave antioxidant. And one interesting thing was the high asparagine content, which improves microcirculation. We formulated many different products, masks, day cream, scrubs, serum, and toothpaste. Finally, after all tests and based on the Eroski recommendations about the market segment that were more interested, we ended up with a moisturizing face mask, which was gel form, which was in a cream form. That was a gel, marmalade-like. That was the cream. And day face cream, which was with an SPF. All of these were natural cosmetics. So these are, for the ones that are interested, they can have the presentation afterwards, the products, and these are the INCI list, the ingredient list. 2% of the product, the orange fruit powder, up to 10% was used in the experiments. That was the same for the mask and for the oil and water cream. And the orange oil, essential oil, was used in all cases as perfume. We made a panel to assess the sensory characteristics of the 3 final formulations. The panel was made with 50 persons, and we checked for the some specific attributes of the products and general acceptance test. So what we saw that for the jar, we checked for convenience, sealing, color, odor, and aesthetic. And at the end, the acceptance test was a little higher than the mid range of the test. One issue, I think, was the odor, which was the lowest score, which can have an impact for cosmetics. The sensory assessment for the day cream and the mask, the 2 masks, you can see the following radiant diagrams. Overall, I think the score was quite good, especially for the day cream. And between the cream and the gel, in our panel, the gel was slightly better. In terms of sensory assessment for the 3 products, we did an acceptance test, which gave an average score for the different users. To our panel, the mask in the form of gel was the product which had a higher score. And I would like to thank you for your attention. This was the end of a big journey and a lot of effort by all the partners. And I think it gave us the opportunity to play and formulate and see how we can explore the citrus byproducts. So thank you and welcome your questions. Thank you.
Thank you, Georgios. And once again, congratulations to all of you for this incredible work. So we have a little delay. Then what we are going to do is to have a break for 10-15 minutes. So we will be back at 11:30, okay? So take this time to take some coffee. After that, we will start with the next session, chaired by my colleague, Lara Escudero, Head of Communication here in AITIIP. So thanks to everybody and enjoy this coffee time.
Hello, good morning, everybody. Again, I hope you enjoyed your coffee break, gaining strength for the rest of the event. Before starting this new chapter, I would like to thank you all for your commitment this past months and congratulations for your results. So we go now to the Citruspack project presentation stage, and Stephen Bertitel, sorry, and Jana Powells from OWS are gonna break the ice in this stage. Stephen studied Master of Science in Bioscience Engineering with a specialization in environmental technology at the State University of Ghent. After his studies, he started working at OWS at 1999, and it is he's currently head of biodegradation, compostability, and ecotoxicity department. He's the author and co-author of several scientific articles on biodegradation, and compostability. And within OWS, he is also responsible for setting up an organization of European projects. Jana is a young bioengineer specialized in environmental technology and ambitious to make our planet a better place. That's a nice desire. Last year, she combined postgraduate studies in climate modeling with a job at OWS as a study director of biodegradability test. In September 2020, she shifted her focus to sustainability assessment. So let's hear then your research results of compostability testing and life cycle assessment. Please go ahead.
Hello, good morning everybody. My name is I will introduce you more on the work and results we have obtained with the Citruspack for the compostability. While later on, my colleague Jana Powells will introduce you on the life cycles. Words about the company makes use of the Tranco technology, which was developed at the University of Kent in 1983, and is the continuous digest technology to the treatment of organic waste in conversion to biogas and fertilizer. The company itself is a spin-off of the University of Kent and was created in 1988. So we have more than 30 years experience in our digest, solid and semi-solid organics. Our sales is about 20 million per year. We have about 120 people, and our work is mainly for export. More than 90% goes to export. Our office, the main office, is located in Kent. Here you see a nice picture of the city of Kent. Picture at the bottom is a picture of our company. It's so nice. We have also 4 subsidiaries: OBS in America, BES Germany, Tranco, which is for the operation of these. OBS in Japan. Now, how is our company structured? In fact, we have 2 main departments. The first one is Tranco Tech, which is on the engineering department. That stands for building and construction of these anode digestion plants you see at the right. We have about 24 plants. A lot of them are built in Europe, also in Asia, and now currently we are building and setting up the plants for big plants in China. Apart from this Tranco technology, we have a lab development and consultancy services. This group contains 5 smaller departments. First of all, we have the PCE department. It stands for biodegradation, compostability, and ecotoxicity, where I am involved. The second one is PCS. They do biogas consulting and support. They work closely together with the Tranco Tech group, as it's very important for these anaerobic digestion technology to understand what is happening in the reactor, what is going on with the biology, and how we can steer it to have a stable process. The third group is the analytic group. It performs just some normal analyzing, trade metals, We're also certified for checking the quality of compost in Belgium. The fourth group is auditing, controlling and sorting. In this group, we check purity of waste streams, and we go at the plant to see if the material is pure enough for to ensure a good recycling, the correct price. The last department where Diana is involved is the sustainability assessment service. Well, let's have a closer look at the BC department. There we want to be a one-stop laboratory for biodegradation and compostability testing. We have more than 30 years of experience in this field and test more than 10,000 samples for about 1,200 customers, and even more now. We are very active in standardization, and we are strongly looking for standardization, not only on a European level, but also on an American level and international level. Furthermore, we are recognized with all certification groups worldwide. We have 2 in Belgium, 7 in Europe, PPI in America, PBI in Australasia, and UPPA, but in Japan. We offer biodegradation testing in all kinds of environments, so compost, soil, in water, fresh marine, landfill, and other anaerobic conditions. Therefore, we do compostability testing on industrial and home compost conditions, and we check also on the level. Next to that, we also see as a contract research lab, and we give workshops. The SAS department, which is Sustainability Assessment Services, wants to guide companies into their transition to more a sustainable company. We measure the impact on people, planet, and profit, and help them to compare with current processes, make suggestions for improvement and for compensation. We can do quite some different services, such as an environmental product declaration. 5, we also life cycle assessments, based on standards. We do that often for European projects like Citruspack, but also other ones. Next to that, we do carbon footprint analysis to energy. So we want to help a company to make it more sustainable. We also develop custom tailored tools and support. Now, let's go to the real testing we have done in this Citruspack project on the juice bottle and cosmetic. We checked if these materials are industrial composting. The standard we use for that is the EN 13432. This is a harmonized norm, which means that it's accepted by the European Commission. The standard defines 4 criteria. First one is on material characteristics. Then we have one on biodegradation, which means that your material must really mineralize into CO2 and water. It must be completely converted. Third one is disintegration. Material added at start of composting process must physically fall apart completely and not disturb the compost visibly. For this characteristic, thickness is very important. The more the thicker the material, the more difficult it will be to disintegrate. Of course, the last criteria is there may not be any negative effect on the compost quality. It's also tested by plant toxicity. Graph below, you can see what's the difference between disintegration and biodegradation. First, you see glass bottle and the criticality. It must fall apart during the disintegration process in smaller pieces, and then it can only be converted by bacteria into CO2 and water. Now, let's go more in detail on these characteristics. So, for the bottle and the jars, we observed volatile solids content of more than 99%, which is much higher than the 50% requirement stated by the standard. Also, all requirements on heavy metals and fluorine were fulfilled. They might not be above a certain level as defined by the standard. Second requirement is the one on biodegradation. First, to reach more than 90% absolute or relative biodegradation within 80 days. Tested, which is usually for is ISO 14885, and which we check the biodegradation of material under composting conditions. Graph below, you see the blue line is the reference material cellulose, which went very quick, and the green line is our test material. So you see that during the first 15 days, not really happening a lot, only a low validation was observed, but it's not uncommon for this kind of materials. It's considered as a lag phase or by invasion. After that, invasion went on at a more constant rate, and we reached more than 90% by invasion within 1 minute. That was a positive result. Also, the disintegration was evaluated, and you should reach more than 80% disintegration within 12 weeks of composting. The standard that was used therefore is ISO 16929. This is a pilot scale composting test, a code simulation for a real composting plant. So for the bottle, it had a thickness of around 0.6 millimeter, we reached 100% disintegration. Quite fast, after 4 days, the material was already falling apart. After 2 weeks, we had only 2 samples left. After 4 weeks, the material was completely disappeared. So much quicker than the long duration of 12 weeks. The jar, it was quite thicker and had a thickness around 5 to 6 millimeters for some parts, reached the disintegration. So it fulfilled the requirement. See the graphs that this nice material, despite its huge thickness, fell apart quite well during the process. The last requirement is the one on compost quality. So your material may not have any negative effect on the germination and plant yield of 2 types of plants. We normally work barley and grass, barley as a monocotyl and grass as a reference for dicotyls. Both products fulfilled also the requirement of compost quality. So we can conclude that this Citruspack project, the bottle and the jars, are completely in line with EN 13432, and they can be used to obtain certificates such as OK Composted of TÜV Austria, receiving logo of European Bioplastics, and the Industrial Composting logo TILSEC. Now I give you the floor to my colleague Jana, which will introduce more on the monitoring of the environmental and economic. Thank you.
Hi everybody, my name is Jana and I will guide you through the final results of the life cycle assessment, and I will start with the environmental impacts. So for the juice bottle, the functional unit is 10,000 bottles of 250 milliliters, and the production consists of 4 steps, namely extraction from the fruit to the waste. Then this waste is dried and milled until a powder is formed, and this powder is mixed with PLA, and that is used for manufacturing the juice bottle in the injection and blow molding. And the final product, the juice bottle itself, is 100% composted in an industrial composting plant. And the product will be compared with 2 benchmark products, namely a PET bottle, which is partly recycled, incinerated, and landfilled, and then a pure PLA bottle, which is also composted in an industrial composting plant. For the results, you can see that the mixing with the citrus waste power and the PLA has the highest environmental impact for all categories. And this is mainly due to the production of the PLA granulate itself. And this final powder consists only of 5% citrus waste power, but still the drying and milling has a significant contribution. But I have to point out that this drying and milling is on the data is on laboratorium scale, so this makes it hard to compare. And we see that for the comparison, the Citruspack bottle has the highest impact for most categories compared to the PET bottle and the PLA bottle. But as I said, the difference in scale should be taken into account and considered. Then for the cosmetic jar, the functional unit is also 10,000 jars, now of 50 milliliters, and the production consists of the same 4 steps, but now only injection molding will be used for the manufacturing and not blow molding, and it's also composted. This will be compared with the polypropylene jar, which is incinerated, and also a pure PLA jar, which will be composted. And here the results, the difference with the bottle is that here the drying and milling has a much larger relative contribution. And this is also because it consists of 20% citrus waste bottle instead of 5 for the bottle. So this 2 first steps has a much higher impact now. And we see that also the difference in total environmental impact with the 2 benchmark products is higher, and the Citruspack jar has the highest impact for all the impact categories. But as the drying and milling step is now more important because of the higher percentage of citrus waste powder, also this difference in scale is here more important. Then for the cosmetic products, the functional unit is now 500 liters, so the content to fill this 10,000 jars. And we considered 3 cosmetic products, so the scrub, the serum, and the face mask. But here a lot of assumption has to be made. There was only data of 1 citrus ingredient, namely the citrus waste powder as before. So also the pomegranate fruit cuts and the oil is modeled as the citrus waste powder. So this is brings uncertainty. And also the after use is not taken into account because there was no sufficient data for this process. And the reference products are the same products but without the citrus waste ingredients. So the results, we see that the mixing is for all 3 products the highest environmental contribution. And this is mainly due to the production of all the ingredients, the chemicals. And we see that for the serum, the drying and milling has a higher contribution, but this is because the serum itself has a much lower environmental contribution compared to the other 2 products. And this is because the serum doesn't require heating, so less electricity is used. And then to compare it with the reference product, the Citruspack product itself has always a higher environmental contribution, and this is because the drying and milling step is skipped here. And then for the economic impact, you can see that for the bottle and the jar, the Citruspack product has the highest cost, especially compared to the PET bottle and the polypropylene jar. But for the cosmetic products, it's the difference is negligible. Thank you for your attention. I went really quick through the results, but you can always ask more questions about the details or when something is not clear.
Thank you, Jana and Stephen, for your presentations. This is quite technical for common mortals, people like me, but it is definitely something huge. Okay, so now let's pay attention to Anders Wiggerfeld, who will explain the validation of prototypes and design facing the consumers. Anders is currently head of private label food department at Eroski. He has a wide experience since 1997, starting in IKEA I don't know the pronunciation, as food service manager. Once in Eroski, he has been also head of multiple departments: import purchasing, shoes purchasing, textile, entertainment, optical and telecommunication, fruit and bread, and project leader in assortment development and store change. Please, Anders, go ahead, proceed.
Hello, I'm Anders Wiggerfeld from Eroski. I am head of private label in Eroski, and I will briefly show you the results of the study we made with final consumers about the development of the products for juice and cream jar regarding appearance, smell, design, and concept. To do this, we work with an external professional company working with consumer insights. They made this in 2 different focus groups, with one with buyers and one with non-buyers. We were present at the study. We were behind a crystal window where they couldn't see us, so we could follow the reactions of the consumers. We did this with the AITIIP, which is a professional company, and we did it on Monday in December 2019. The first thing we wanted to find out is what will be the acceptance about the appearance of the container. The first impression was very positive because the look and the design of the material made associations to recycle and natural product. So we can say that for the citrus bottle, it was very positive. It was, even though some consumers would like to have a transparent container, they found it very close to a container you could expect for an eco-friendly product. The only thing we found quite negative was that there were some smells from the material. It could smell like, the consumers could smell like coffee or licorice. It was negative in the sense that when we asked them what they would think about having this container for juice or cosmetic products, they were a bit reluctant because maybe this could transfer to the product. They said that it would be perfect for a ready-to-go coffee, for example. When we asked them about the design of the products, we less material is better for eco-friendly products. So in this case, with the 2 ones, you can see the one with less label on the product was more positive. They also said that it's very important that all the material we use for the bottle is made of eco-friendly material. For example, we cannot use a tap made of aluminium in this bottle. So all the concept should be made of same kind of material, or at least if it's plastic or paper, it should be recycled and in the same way. When we asked them about the concept, about the different eco-friendly definitions like bio-based, biodegradable, etc., we found out that the consumers in general have very little knowledge about these concepts. And when we speak about technical concepts, it's very difficult for them to understand what we tell. So it's very important that when we want to construct a message to the consumers, that we make it with simple words in a language they understand. It's just as important the way we communicate to them as it is the proper development of the product. So in general, we can say that the main conclusion is that the 2 containers, both the one for juice and the one for cosmetics, generates good acceptance, both as a concept, because people are getting more and more aware about the importance of being eco-friendly and also organoleptically. But there were some limits, as I said there, about the concept. It's difficult to transmit technical definitions to the consumers. So we have to construct a language which is easy for them to understand. And about the size and shape condition for the context, for example, the bottle is not associated with water, nor the cream container with toothpaste or hair mask, if we would like to use it for that. And as I said, we should not mix different materials which are not eco-friendly. And we should be very careful to make sure that we don't have a material that makes any bad odor with the product. There are some opportunities. We asked them about different colors of the material. We had different colors, and above those different colors, the one that was most accepted was the one we've seen in the on the photos, like a brown one. It's more associated with eco-friendly than, for example, a more reddish or bluish one. The cream container clearly contributes to the positioning of a differential product with an added value. It could be used for a high value-added product with a natural product. Although both containers generated positive reactions, the most positive ones are shown by those participants who show a greater environmental sensitivity. That is, we asked the consumers if they would buy this product, and more or less all of them said, yes, I would, if the price is the same. It's common known that no one is prepared to pay more for an eco-friendly. Maybe some consumers that are more that knows more about eco-friendly products, they would do it. The cream containers is less controversial than the bottle. It's easier to make a product that you can see for a cream than for a liquid. In this sense, those participants less sensitive to environment are not as attracted to the colors and textures of the bottles. That is, if you offer a product that is not eco-friendly and it has the same price and they can see the product in a transparent plastic, maybe they prefer to buy that one. Both the label in the cases of bottles in the box and the case of cream containers contribute to improving the positioning of the packaging container and the product container, enhancing the positioning of the product and natural packaging. This is particularly supported by the fact that the images are of high quality as well as the presence of plant products. When we make the label, we had a prototype of the label, and as you've seen, it was with a had a present with plant products, try to make it more real, etc., and it was positive. We think that for a final product, we have to test this more with final consumers to get the real concepts, because this was a prototype. So that's a very short and brief resume of the consumer study. You have the presentation there, and I would just like to thank all of you with whom we have been working during this project. Thank you very much on behalf of the Eroski.
Thank you, Anders. Definitely the eco-friendly concept will define, hopefully, our future. We arrive, people, to the end of this stage, and it is Sylvie Charel time from Plastipolis. Bonjour, by the way. She will report her team results in transferability and replicability. Sylvie is the Innovation Project Manager, Flexible Plastic and Packaging at Plastipolis. With a background dedicated to packaging, Sylvie works since several years for helping plastic companies. She was a project manager in the GCE Plasturgie cluster during 8 years before joining Plastipolis in January 2018, dedicated to the fusion between Plastipolis and the cluster. She integrates a double competence in packaging and management of projects. Go, Sylvie, please.
The goal of replicability and transferability strategy is to multiply the impact of the project results during its implementation and to replicate and transfer its finding after its end in order to reach a wider audience and implement its results in further sites and regions, other than the Citruspack project demo site. The replicability and transferability results on other application processes and new applications in other sectors. Today, I will present a few examples of transferability in different companies: Hula, Mar, ITC Packaging, Biotop, Tacolepo, and TECOS. So, we have worked with the society Mar, located in Slovenia, which produce packaging nets for fruit and vegetables. Mar offers a variety of food packaging netting, which all meet the requirements of hygiene and aesthetic. The manufacturing method is wire extrusion. So you can see that Citruspack materials allow to produce packaging nets in different colors. The new pack material was adapted with wire extrusion. Also, we have worked with Hula Labs company. It is the design brains behind Hula, a smart and engaging contemporary wellness tool that helps people live a healthier life. It's an innovative high-tech SME located in Slovenia and globally present in all world continents. They have developed a device for reminder to drink water. The replication project was to design a device which allowed to drink 3 more water, to get healthier, to have more energy and avoid HHs with Hula, your personal hydration coach. The device can be fit on any water bottle. As you can see on the photo, some samples could be made with Citruspack material, also in different colors. On this slide, you can see that the device made of Citruspack material can be fixed on the bottle. So the material is adapted to this technology. For transferability and replicability, we also wanted to share the results with another European live project named Biotop. The objective of this project is to replace the polypropylene on fields with bio-based products made of PLA, which is produced from renewable resources. It also aims to demonstrate the value and potential of post-harvest biomass, thus promoting a new circular economy model for improved agricultural waste management. It combines bioplastic twinning materials with new ways to use crop waste in packaging and horticulture products. Citruspack material is a solution, and some sample of planting pots has been realized. So you can see on the photo the planting pots. We have proposed to ITC Packaging to test the Citruspack material. ITC Packaging is a Spanish company dedicated to injection process. They have a wide range of products as packaging for baby food, packaging for chemical products, cosmetics. In this case, we are going to focus on yogurt packaging. The Citruspack material is accepted by injection technology, but results are not acceptable due to thickness. The pot is brittle. It is due to the PLA. So we know that some improvement on the material must be made. You can see on the video that samples are really brittle. So new formulation and samples will be made by AITIIP, and some specific points like thickness, brittle material, color will be studied to provide a perfect solution. During the project, we also have been approached by other stakeholders like Tako, a Slovenian company specialized in natural cosmetic, who is interested in Citruspack cosmetic packaging for their deodorant cream. TECOS, partner of the project, used the material to develop a promo gift edition given to their clients. Also, the stationery state developed is a communication tool to find new customers potentially interested in the new material. Thanks to all the dissemination activities during the project, we have been approached by different stakeholders. All of them are interested by the new Citruspack material. We can say, for example, in France, that Belfort, a company specialized in thermal farming, is interesting. We have also Naturplast, a compounder of bio-based material, who would like to have more information, and so on. Secondly, we can say that the developed bioplastic material can be processed through several different conventional plastic transformation technologies. And firstly, several new markets and products can use Citruspack materials. Thank you for your attention.
Well, thank you, Sylvie, Jana, Stephen, Anders, and all your teams for your work these years. We got finally to the question round, and we have already some for you. So let me see. One goes to Jana and Stephen. Why is the advantage of a product to be compostable? And you have also another one. Why does Citruspack jar deplete more resources than the PP jar? Jana, Stephen, feel free to answer.
Hello, good morning. This is Stephen from OWS. I will take the first answer probably, and the other one is more on the life cycle assessment, which is for Jana. So what is an advantage for a material to be compostable? The way now it is that most plastic or most packaging are not really recycled. They are mainly going to incineration, or even worse, they go in landfill. So the advantage if a material can be converted to composting in a kind of fertilizer, you do something valuable with your product. You have a more circular approach than just burn it away. And especially for packaging and even for multi-layer packaging, recycling is materials very difficult. And the advantage of organic recycling is that if packaging is polluted with organic materials, which is often the case for food packaging materials, you can just treated in the same way together with the organic waste and converted into fertilizer. And also these facilities, these composting plants are already existing. So that gives some benefit, an additional benefit. You don't have to invest in other plants, and it's an approach you can easily obtain already at this moment. So that's the major advantage. And I can give you for the next question to Jana.
Yeah, next question. Jana, please, if you can proceed.
Yes, for the second question, so indeed, polypropylene depletes much more resources than PLA, but here it's the reverse. It's comparable because the Citruspack jar has a much larger weight than the polypropylene jar, so that's why more resources are depleted, and also because it's the Citruspack jar is on a pilot scale, so more electricity is consumed, and this makes the Citruspack jar more harmful for resource scarcity.
Okay. Thank you both. If you have finished, let's move on to the next two questions. In this case, Carolina, AITIIP. Do you think that the bio bottle could have other uses rather than food sector? And another question for you, why have you developed a 3-layered bottle? Please, proceed.
Thank you, Lara. Okay, I will answer first the first question regarding to the other uses for rather than food. Well, we have envisaged also some other uses. For instance, in the same sector that the cosmetic sector that we have been also studying during the project, because this bottle could be a good packaging for products like, for instance, a cream moisturizer, a hand soap, but also we think in another sector, like for instance, for products like fabric softener or washing machine soap, this kind of products, always looking for a more sustainable consumer point of view, because obviously, as we have been seeing, these bottles are expensive. They have more cost than conventional ones, but on another hand, they give us some other benefits to our planet. And the other questions regarding the 3-layer bottle, this is because we wanted to launch the bottle as soon as possible. So in the case of having a PLA layer inside of the bottle, give us the opportunity to have a material completely certified already for food contact, and at the same time adding the citrus powder obtained in the project. So this way we accomplish with all the requirements. It's compostable, industrial compostable, it's approved for food contact, and of course it has been approved with the IMC in the flash pasteurization. So this is why we have developed a 3-layer bottle. Thank you.
Thank you, Carolina, for your explanation. Maricruz, AMC, this to go to you. Why is that bottle made with the shape and size? It is possible to use this bottle for any juice, refreshing drink, or carbonated drink. Please, your turn. I think, Maricruz, you have to.
Now?
Exactly.
Okay?
Thank you. Yeah.
Okay, sorry.
We can hear you now.
Yeah, okay, sorry. Okay, regarding the first question, why this shape and this size, we start here in collaboration in the company with our marketing department. So we design a consumer study because as we are always focusing in the market opportunities, and we try to understand what was the best option for the final consumer. So finally, we design a consumer study, and the bottle at the end, the design of the bottle was chosen by the consumers. So this is we are pretty sure that once we success to be in the market, it will be a success product because we involve the consumer from the beginning. Okay. And regarding the second question, if we can use for other kind of product, first of all, we are starting in the start of the usage, that is orange juice. So that means that the fruit, more or less orange, apple, pineapple, all the let's say normal fruit have more or less the same pH. We have all the fruit in the same range of pH. So that means that once we validate and we finish the cell life study with the orange juice, we will be ready to fill all the other fruit with this in the same range of pH. But regarding carbonate, this is something that we have to initiate the study and the research from the beginning in the validation, because we have now some information about pressure in the treatment of HPP. So we know that this bottle now is not so happy with pressure, and once we carbonate the drink, we have to apply the CO2. That means that we are going to have again some pressure. So that means that is a new challenge in front of us, because to fill carbonate the beverage, we have to start with the same validation test, because we don't have experience with the carbonate. And okay, any questions?
Okay. Thank you, Maricruz.
Okay, you're welcome.
Oh, questions. This time for Sylvie. Sylvie, do you plan to use the Citruspack material developed in other markets?
Yes, we are available to test the material in other markets than those presented and tested during the replication. I could say that if someone wants to develop a new project or to test the material, they can come back to us and to Carolina to talk about the specification, the transformation technology, and we will be able to propose a solution. But it can be used in other market. Yes.
Okay, thank you. Vesna, TECOS, you have a question too. Okay, what are the appropriate options for disposal of Citruspack biocosmetic jars after the end of life use?
Hi, hello to everyone. I hope you can hear me well. Yeah, well, of course, like also bottle, also jar has to be disposed in organic bins. So all the post-consumers have to take that in their consideration when they are finished to use it, this packaging or the cream, for example, in the case of biojar. So when it is empty, you just have to place it in the organic waste bin, okay, and wait for the collection of the management waste systems. because yeah, in the consideration that these materials is basically composed of bioplastic called PLA, so polylactic acid, it has to be properly composted, like there was said before in the previous presentations. So if this is not considered biocompostable, if those wastes are not properly composed in industrial composting conditions. So this is the case for both the biojars and biobottles.
Nice. Thank you, Vesna, for your explanation.
You're welcome.
And, yes, please.
You're welcome.
Thank you so much. Okay, so one more last question. In this case, Georgios, OLVETIA, could any of the products be used in cosmetic formulation in the future? Your turn. Hello?
Well, maybe they have some connection problems.
Yeah, probably. Maybe, yeah, Giorgio or Alexandra could answer below the chat or even by email, whatever. So thank you to all of you. It seems we all are a bit closer to a more sustainable behavior notion, maybe, to make this planet a better place, as Jana and all of us desire. So, are you hungry? And what about having some lunchtime now? Take your time, and well, not too much time, because we will back here in 30 minutes. So see you later.
Okay, thank you.
Bye-bye.
Bye-bye.
Bye.
Thank you, Lara. See you later.
Thank you to all.
So welcome back to the final session of this final conference. I hope you have enjoyed your lunchtime. First of all, I would like to inform you that Alexandra from OLVETIA has give some answers to the last question, because there were some problems with the mute button, so she cannot unmute. So she has give answer to the last question in the chat box. You can find it, their answers. And also there was another question from Marcello Vitale in the questions and answer box, and I have answered to him. You can see the answer and the question in the question and answer box. So continuing, as I said, with the last part of our final conference, we will be now having three presentations of different live projects, also focused on the circular economy and the revalorization of valuable ingredients in different uses. So the first presentation will be done by Vanessa Martinez. She is industrial engineer with a specialization in material sciences. She is master's degree in biomedical engineering and has a PhD in mechanical engineering. She has been working as a surface engineer for 12 years on the reduction of surface degradation processes of metallic and polymeric materials. Her expertise is focused on the development of protective coatings to improve the functionality of components for the biomedical, automotive, energy, and manufacturing sectors. At Technopackaging, she is developing novel multifunctional bio-based coatings based on PHAs, PLAs, for the food packaging projects, with the aim to improve their barrier properties and their recyclability and compostability properties. Go ahead, Vanessa. Well, Wait a minute. Let's see.
Good morning, everyone. First of all, I would like to thank Carolina for inviting Technopackaging to present our project Biotop in the Citruspack final conference. I'm Vanessa Martinez, European Project Manager at Technopackaging. During the presentation, I will briefly introduce the company, our solutions, the main technologies and services we have, and the European project in which we are currently involved. Afterwards, I will present in which context is focused the Biotop project, the consortium partners which are involved in it, and our role during the project. I hope you find of interest the content of the presentation, and if you have questions about it, we can discuss them during the questions and answers session. Technopackaging is a technology-based SME involved in the development of innovative plastic materials and products. We are based in Zaragoza, a city in the north of Spain, in between Barcelona and Madrid. We are currently 42 researchers and technicians, and we work for about 80 customers. We are always improving our facilities with a 0.5 million euros of investment in equipment per year, and during the last year, we reached an annual budget about 1.8 million euros. We are specialized in tailor-made solutions for our customers, developing and producing plastic compounds and products according to their specific needs, thanks to our past and present experience. Among the materials we usually work with, we have technical polymers such as PEEK or PPS, and also biopolymers and nanocomposites. Another point of our expertise is the generation of smart products with additional functionalities, such as antimicrobial, antioxidant, or barrier properties. Another interesting research line is our work on sustainable products, focusing on the improvement of recyclability, biodegradability, and compostability, together with the revalorization of agro-wastes. Additionally, our facilities are also ready for material validation at pre-industrial scale. As you can see in this slide, Technopackaging, since it was created in 2010, has participated in a total of 14 European projects. During this project, we have contributed to the development of new formulation of bio-based materials for food packaging, such as in Europa, Whitepack, Newpack, or Fish for Field, and we also have contributed to the valorization of agro-wastes, water wastes, or animal waste, such as in Biotop, Barbara, in Green, or Unlock, and also in the improvement of the recyclability of bio-based materials, such as in Feedback. So once we know what Technopackaging does, it's time to present our Biotop project and our specific role in it. At European level, there are 50,000 tons of hops produced on a surface of 26,500 hectares. Slovenia produces nearly 2,800 tons on 1,090 hectares annually, and it's currently ranked as the third European largest hop producer and the fifth in the world. The hop agricultural sector is the largest exporter in agricultural segment in Slovenia. Therefore, it also has a great meaning for Slovenia's international visibility. During the hop harvest, the entire above-ground mass of plants is removed from the field, and after the cones are harvested, the rest of the biomass, the leaves and the vines, are left behind. They are a valuable source of organic matter and nutrients for returning to agricultural areas. However, the problem is a synthetic polypropylene twine, which is used as a support for hop plants during growth, as it remains intertwined in hop biomass after harvest and does not decompose by composting, preventing the use of this biomass as raw material and at the same time creating a huge environmental problem. So, who is thinking about an efficient solution for that problem? Biotop Consortium forms a transnational partnership comprised of 7 partners from 5 European member states: Slovenia, Portugal, Spain, Germany, and the Czech Republic. The Slovenian Institute of Hop Research and Brewing acts as a coordinating beneficiary, runs its principal functions on research, advisory services, and green managing procurement for sustainable hop growing industry. The Portuguese Lahor's Euronet group is in charge of development of home compostable PLA twine for hop growing sector, while Selfo Technology is developing a technology to re-engineer hop waste fibers to be usable in fiber pulp molding application and extrusion compounding transforming processes. Trigas from Czech Republic leads the piloting action on hop waste fiber transformation into pulp molded packaging products. Technopackaging is developing and producing hop fiber PLA compounds for injection piloting and replication on extrusion blow molding for the production of films from biotop materials. Technopackaging's prepared materials are used by TECOS for the injection molding of planting pots for horticulture, in particular for the hop seedlings cultivated by AITIIP. The third Slovenian partner is the development agency Savinja, that united 6 municipalities of Lower Savinja Valley, which is the Dirmo region of the project and the largest hop growing region of Slovenia. Their presence will stimulate active hop growers' involvement, disseminate, exploit, and transfer the project results regionally and transnationally. Then, which benefits will bring Biotop project? The 3 main benefits of Biotop project are: 1. To revalorize the hop waste in hop production. 2. To improve the energetic efficiency by 25% using biopolymeric composites instead of fossil-based composites. And 3rd, to reduce the greenhouse emissions compared to conventional plastic production. To do so, Biotop project is implementing a circular economy model in which the hop waste biomass is used as raw materials for 2 different value chains, the pink and the blue in the image, and an additional circle in black for the introduction of bioplastic twine. The advantage of introducing this biotwine made of renewable PLA material is that it can be degraded by composting to simple monomers and biomass, and being used at the end of their lifespan as nutritional enriched compost or natural fertilizers. Furthermore, hop plant biomass after harvest is treated by Selfos technology twofold. On one side, the pink circle, the hop fibers are re-engineered and adapted for pulp molding processing for the obtention of packaging trays, and on the other hand, the fibers can also be treated to be processed by extrusion compounding to produce hop-based reinforced composites that will be further used by TECOS to inject planting pots 100% compostable, biodegradable, and recyclable. With these 3 approaches, it's clear that Biotop contributes to drastically reduce the use of fossil-based materials, and the economy of the sold agro waste to bioplastic producers can be increased. The methodology followed during the project is firstly the obtention of the hop agro waste, which usually includes hop leaves, vines, and PLA residues. Then, the second step is to valorize the hop fiber material and the enriched compost. Afterwards, the biomaterials obtained are given a specific functionality depending on the final application they are intended to be used during the validation phase. These 2 functionalities are self-binding for the pulp fiber substrates for the packaging and reinforcement agents for the injection of planting. Finally, during the validation and production line, each of the materials produced during the different stages and harvesting seasons of the project is in the validation production stage of the project, where Technopackaging performs most of its tasks by creating novel hop-based reinforced composites by extrusion compounding. Technopackaging's role is focused in the validation production phase and also assists the other partners in the development of protocols to transform the hop fiber into a fiber that can be used as reinforcement agent in the planting pots. So, after the harvesting seasons and the processing of the fibers at Selfos, several grades or types of fibers are obtained, as you can see in the pictures. The most important things we need to consider when developing new biocomposite formulations are: the hop fibers should be as dry as possible. We need to maximize the content of bio-based materials, while at the same time the formulation needs to be processable for injection. And finally, we of course need to meet end-user requirements. The pot needs to be flexible, over 5%, and to be as cheap as possible. The compounding process performed at Tecno consists of several steps. First, the content of humidity should be reduced as much as possible. Therefore, the hop fiber is dried in an air oven overnight at 40 degrees Celsius. Also, the biopolymers we use to integrate the fiber and have processable materials are also dried. For the extrusion process, we use an industrial extrusion compounding system with a double screw and several feeders. The feeding components and the system parameters have been adapted specifically for the processing of the hop fibers, including the feeding and the screw speeds together with the processing pressures and temperatures. After the feeding phase, the screw temperature is increased until the biopolymer is melted, but without damaging the fibers. The melted mixture is extruded through the cylindrical die at high temperature. Since the obtained filament is at high temperature, a cooling down phase is needed and a water bath is used for that purpose, for a couple of meters. Finally, once the filament is at a reduced temperature, it is pelletized, dried to remove the excess of water and stored to be sent to TECOS for injection trials or biotop planting pots. As an example of the demonstration phase performed during the project, the hop fiber reinforced composite has been compared to other standard materials in terms of processability properties. In the image, you can see a polypropylene and a PLA pots on the left-hand side, and the pots fabricated by using different percentages of hop fiber. The change of color corresponds to the decrease in the percentage of hop fiber content. In summary, since the beginning of the project, the whole consortium has reached some relevant milestones, such as the introduction and testing of biotwine in the demonstration fields that will be possible to be used as compost and on fertilizers in the next hop season, the production of hop fiber-based biocomposite with a hop fiber content between 30 to 40%, and the production of injected planting pots. So that's all from my side. I would like to thank you everyone for listening. Of course, if you want to find more information about the project, you can visit our website or our social networks, where we publish our news regularly. Or you can also contact me or any of the biotop partners for further info.
Thank you very much, Vanessa, for your interesting presentation. Now we are moving to the next one, which is the Life Brewery, new strategies for improving the sustainability of breweries' food waste recovery for high-value solutions. This Life project is going to be presented by David San Martin. David is a researcher in the area of efficient and sustainable processes at AITIIP, leading several projects related with the valorization of food byproducts for different value applications related to human and or animal nutrition. He is specialized in bioprocesses such as enzymatic hydrolysis and different dehydration technologies, as well in the application of multi-criteria decision methodologies in the field of circular economy. So let's go listen to David. The floor is yours.
My name is David San Martin, and I'm going to present the Life Brewery project, which is focused on the developing of new strategies for improving the sustainability of breweries, food waste recovery for high-value solutions. AITIIP, which is a food research center, is coordinating this project, and the other partners are the Breweries of Europe, which represents the beer industry, IRTA, which is a research center specialized in aquaculture feeding, LKS, which is an engineering specialized in the building of food waste valorization plants, and Riranade, which is a technology provider specialized in the watering and drying technologies. I'm going to divide my presentation into 4 parts: objectives, benefits, technological solution, and demonstration at semi-industrial scale. Regarding the objectives, the general objective is to define and demonstrate the feasibility of innovative and sustainable technological solution to valorize previous byproducts as secondary materials for new high-value approach. And we expect to define to demonstrate this solution at semi-industrial scale and in a real operational conditions and in a real case study representative of a European brewing producing region, the northeast part of Spain. To achieve this general objective, we have two different specific objectives. The first one is to assess the potential of hydrolysis to obtain high-value compounds for human consumption and to increase the ingredients' digestibility to give more value to the products byproducts for aquafeed applications. And the second specific objective is to develop an innovative and efficient drying process which ensures the nutritional quality, the food security and safety, and the economic feasibility for obtaining 4 different ingredients: dried spent yeast, hydrolyzed and dried spent yeast, dried spent grain, and hydrolyzed and dried spent grain. Regarding to the benefits, the first benefit is to provide a high-value solution for beverage byproducts, contributing to the sustainability of beer industry. First of all, we can produce new food ingredients as a high-value solution for beverage byproducts, and secondly, we can produce aquafeed ingredients, which are a value solution for large quantities of beverage byproducts. We also offer an increasing of the sustainability of beer industry, increase the competitiveness of the beer industry by implementing a new business activity based on circular economy, and the solution that we propose is environmental friendly because we produce a secondary raw material from beverage byproducts by eco-designing the production plant. Regarding to the technological solution, we have included the best available technologies. The first step is the hydrolysis. We propose an enzymatic hydrolysis to obtain high-value molecules and to increase the digestibility of obtained ingredients. The second step is a dewatering process, including a decanter or a centrifuge, which are more efficient and less energy demanding than the third steps, that is the thermal drying, in which we propose an innovative technology such as flash drying, which is high efficiency but more energy demanding. In this slide, you can see the recovery scheme that we propose, in which all the stages of the value chain are included. This solution is innovative, safe, and secure to produce food-grade ingredients for human consumption or other approaches, and all the time maintaining the nutritional value. This solution is replicable to any other European region because it's flexible and adaptable. It's sustainable because we apply the co-design methodology since the beginning, and it's high efficiency because it's low energy demanding and is adaptable to any energy source. Once the processing process was defined, we have eco-designed the production plant by applying the eco-design methodology, in which the different topics has been considered. For example, the location analysis, the bioclimatic designs. We have considered also environmental certification criteria. The material and structural selection is based on LCA methodologies. We also have considered the responsible sourcing, the European legislation, and we have performed different energy simulations. Finally, we want to highlight that a trunking solution is available for processing all the beverage byproducts with these technologies. Finally, I want to speak about the demonstration trial that we have developed. The scope of this demonstration trial was the northeast part of Spain, which we consider that is a representative case study. The demonstration trial has been developed at semi-industrial scale and in a real operational conditions, because we have processed 15 tons of each ingredients to produce 1.5 tons of beverage spent grain and beverage spent yeast ingredients. Regarding the first application, new food ingredients for human consumption, we highlight the nutritional value is based on their high protein content, and we also guarantee the application aquafeed ingredients. We test obtained ingredients with real heat disciplines as a model of marine aquaculture and rainbow trout as a model of freshwater aquaculture. And the obtained result has been very positive. We consider that they have adequate digestibility for fishes. Digestibility test has been positive with a high level of inclusion in diets, 20% in bread spent yeast and 50% in bread spent grain. We also consider that these ingredients are high nutritional value because the grow and feed efficiency trial has been positive, no difference with control. And also we have developed some sensory tests which has shown no difference with control. Conclusions. Based on obtaining results, we can conclude that the proposed technology solution is innovative, safe, and secure. It includes all the stages of the value chain. Feasibility of this solution has been demonstrated as an industrial scale. Is suitable for food grade and other approaches. Combination of human consumption and aquafeed ingredients is possible. We maintain the nutritional value, safety, and security during all the process. The solution is replicable to any European region because it's flexible and adaptable to any scenario. It's a sustainable solutions because we have applied the co-design methodology since the beginning of the proposal. It's a high efficient solutions with low energy demand and adaptable to any energy source. And a toolkit solution is available. I want to say that this project is funded by LIFE European Environmental Programme, and I would like to thank the collaboration of Mau San Miguel and Nuevo Things Company. Thank you. If you need more information, you can send me an mail, and if you have questions, I will answer them. Thank you.
Thank you very much, David, for your presentation. Very interesting project. Congratulations for all your developments and achievements. And I wish you all the best in the post-project phase. Now, we are going to finish this third part of the final conference with another live project. This is called Live Oleo Regenera, Valorization of Bio-Waste resulting from the olive oil extraction process. This project is going to be presented by Laura González Ramiro. She is graduate in biology with a specialty in biotechnology from the University of Murcia. She has a master's degree in plant productivity and health from the University of Murcia and a second master's degree in agro-environmental science and sustainable agriculture from the Autonomous University of Madrid. He has more than 12 years of research experience in the field of fertilizers, phytosanitary products, and biofertilizers. He is currently production manager and research technician at FINECO, where she is in charge of the development of new formulations, project registration, ecological certifications, and product control. The floor is yours, Laura. Go ahead.
And thanks to Doctora Carolina Peñalba for inviting us to this live Citruspack final conference.
First of all, I would like to introduce myself and our organization. My name is Laura Gonzalez. I'm Research and Development Technician and Production Manager at TECOS. TECOS is an enterprise born in 2015 with the aim not only of providing high quality and eco-friendly products for the field, but also of keeping a comprehensive service to the farmer. We produce fertilizers, and between 80 to 90% of our catalog is suitable for organic farming. We develop and implement our own formulation strictly complying with the current legislation. Our marketing, researching, and commercial team are composed by great professionals, young but with long experience in the sector, and above all, eager to do things well. PINECO has been awarded with several supporting programs to develop its projects since its inception, while it was carving out a niche in a sector as competitive as fertilizer market. Among others, we are currently involved in international projects like Life Olea Regenera, in which we are the project managers, coordinators, and responsible for project communication, and Horizon 2020, so Liberagro. We are also carrying out our own project in collaboration with main research centers and universities. Recently, PINECO has received the Innovative SME certification by the Ministry of Science of Spain, showing that PINECO has developed innovative solutions to technical and environmental problems. In 2018, PINECO embarked on an exciting 45-year-long project to valorize a bio-waste resulting from the olive oil extraction process, with excellent partners as Orujo Frío, Olivares do Sul, and Cebas de Sic. The aim of this project is to demonstrate the valorization of the bio-waste resulting from the olive oil extraction process, the alperujo, by transforming it into new byproducts that can be used as functional animal feed or biostimulant for crops and reducing pollution power of the olive oil sector. Other objectives are to design and implement a new process in olive oil mills that will transform the waste generated into new byproducts. A second objective is to choose these byproducts to create and validate new products that will be efficient, fair waste, and eco-friendly. Other important objective is to reduce waste and pollution generated and energy required for waste disposal process that will allow us to include the olive industry within the circular economy. The final objective is to obtain better agricultural and livestock products. Here you can see a diagram of the process followed. S is for solid fraction and L for liquid ones. From the alperujo, we obtain two byproducts, S1 and L1. S2 and L2 are obtained from decantation of L1. S1 and S2 are the byproducts used to obtain value-added animal feed products. And L3 is the byproduct we use to develop new fertilizer formulation and also for animal feed. At this point is where PINECO contributes with its knowledge to valorize byproducts L3 as biostimulant for agricultural crops. Using L3 concentrated fraction, we have developed 6 formulations of biostimulants and bioprotectors. The project will have very positive impact at environmental and economic levels. Thanks to this project, it is possible to value and introduce into the market a product that is currently treated as a waste. This will also contribute to minimize the serious environmental problem caused by the presence of harmful pollutants in the gases emitted by orujeras with a high cost over human health and air quality. The expected results include to create a new process through physical methods that could be replicated by other orujeras, to reduce up to 100% the olive oil extraction waste, to obtain 2 byproducts that will be used as raw materials, a solid fraction with low production cost and a high concentration of excellent nutritional quality vegetable fats, and a liquid fraction with also low production cost and high polyphenols concentration. To develop value-added products with biostimulant and protective character that also provide antioxidants for animal feed and crops fertilization, to reduce the tons of alperujo, CO2 and pollutants emission, what means less energy consumption. Other prior results will be technical and economical feasibility studies. to install the alperuco separation process in other olive mills and replicate the process. Cost-benefit analysis, market study, business plan, and exploitation plan of the proposed system and byproducts. Socioeconomic and business benefits for the participating companies that aims to commercialize new products whose characteristics will make them unique to the global market. In long-term results, once the viability of the alperuco separation process and the byproducts have been assessed and its positive impact on the environment has been proven, great interest in implementing this technology is expected in the olive industry. The profit that is expected to be achieved after the commercialization will create an obvious economic interest that will allow the project replication in the years beyond the project. Thanks for your attention, and if you have any questions, it will be a pleasure for me to answer them. Thank you.
Thank you very much, Laura, for your presentation. Very interesting project you have, and I wish you all the best. You have ahead at least one more year of project. So I hope you finish the project with very good results.
Good morning.
Now we are going to have the questions and answers for this session 3 for the 3 live projects presented in this session. We have some questions already for the from the audience. Let's see. First one for Vanessa Martinez.
Hello, Carolina.
Hello, Vanessa. We have a question for you. In which other types of products are you thinking about to use the biotop fibers during the replication activities? And do you think the formulation will be the same? Thank you.
So thanks, Carolina, for your question. So the plan during the replication activities is to use the biotop fibers to be part as formulations for injecting automotive parts. And also we have another replication activity where we are planning to include the fibers, the hop fibers, into protective agricultural mulching films. Of course, one of the requirements in the biotop planting pots is the flexibility. On the opposite side, we have rigid parts for the automotive injection parts, and also extra flexibility and a much thinner thicknesses for the agricultural films. In that sense, the formulations will differ one from the other, but we are working really hard during the project, trying to have like an extensive list, let's say, of different formulations for different applications.
Okay, thank you very much.
Welcome.
A question for David San Martin. Hello, David.
Hello, Carolina.
Do you have any feedback about the acceptance of these new ingredients from the users, aquafeeders?
Yes, the aquafeeders has been involved in the monitoring of the trial with fishes at the beginning of the project. They have advised us how to formulate diets and this thing, and we have shown the results with them, and they say to us that this ingredient have potential to be included in their diets. And now we have to speak about the economic issues, to put a value or a price for this ingredient. So this is the following step with them.
Yeah, it's important too. The economic part. Yes. Thank you very much. A question now for Laura.
Hello.
Hello. Somebody is asking about the S3 part and which occurs to it after the process.
Yes, the S3 fraction barely represents the 2 or even the 1% of the total mass balance, so we can disregard it. But despite this, the S3 re-enters the process at point 1 to undergo the whole process again. And I think this will work, and finally we will have no waste in this in the olive industry.
That's very nice. Another question for David. When do you expect to have the first production plant in operation? Had any contact with interested investors?
Yes, as I said before, we are now with the economic assessment of this activity, this new activity, and we have in contact with some breweries and some investors, and we expect to put the first plant in 2 years, more or less. But now we have to work hard to get it. So probably for the 2023, we are going to start with this activity.
So this is very good news.
This is the objective, but we don't know yet.
Yeah, of course. Finally, I want to ask one more questions to Laura and Vanessa. The first for Laura is how you are gonna solve this COVID situation, because the COVID situation is lowering all activities and in projects also.
Well, we have suffered several setbacks to stabilize the qualities of the byproduct, mainly for the L3 fraction, and the possible toxicity due to its polyphenols and salt concentration has made necessary to carry out several analyses by Sebas to find the most beneficial and appropriate final concentration. And referring to COVID-19, these studies were interrupted in March 2020 because of the COVID-19 pandemic, so this has been finished later than expected. With the results of these trials, FINECO has readjusted right now the initial formulation, and they are all now ready to be tested in plants. So we hope to end and obtain all the results in time. We will be in time in spite of all these setbacks suffered.
Okay, thank you very much, Laura. Good to know that it's everything going well. And finally, for Vanessa, do you think the fibers from different harvesting seasons will be behaved in the same way, and if this can affect the properties of the final products?
Of course, I mean, in theory, each harvesting season might be different one from the other, because at the end it's an open space and the fields grow in a different way. But the hop fibers will have the same quality each season, and we can ensure the quality of the products once they are treated.
Okay, thank you, Vanessa. There is some problems. I don't know if the audience is listening to you well, but in any case, if there is some other question or doubts about this answer, please let us know. You have the contacts of the myself and Vanessa, Laura, and David. In the WhatsApp number, there is no more questions, and I'm trying to see if in the questions and answers section of the WebEx, it's some other questions. I think there is not. So thank you very much to you for being today with us, Laura, Vanessa, and David. Thank you for accepting our invitation. I know it's difficult to prepare this kind of presentations, but I hope some synergies and other ideas could come from this networking session. Thank you so much.
Thank you to
Thank
you.
you. Thank you to you, Beth.
Bye.
So now I would like to give thank you to EASME representatives that are accompanying us today, and of course to our project advisor, Milena, also to our project monitor, Maria Rodriguez, and now Patricia Serrano. They are always supporting us. To the LIFE program for financing, for funding the project. And of course, very special thank you for all our partners, to AMC, to OLVETIA, to TECOS, to Plastipolis, to Eroski, of course. All of you have made this project possible, and I would like to give you a big thank you for all your work during these 3 years. And finally, also give a special thank you for my colleagues at AITIIP that have been working with me, and for also to Lara and David that has been supporting the final conference today. And now,
sorry, yeah, thank you, Carolina.
Thank you. And now, before closing, I would like to take a picture. So I will stop sharing my screen. Please put your cameras on. Lara, please.
Yeah.
When everybody is ready.
I'll be in charge.
Sorry.
Yes.
I'm trying to
sorry.
go from one screen to another. Okay.
We have to expand a little bit the screen.
Let's see. You can change the layout to grid and to have all participants.
Okay. A big smile. I have to do different captures, so wait a minute, please. Hold the smile. Okay. One more. Oh, Carolina, now you are the big face in here. Okay. Next one. Maricruz, Steven, Sylvie, Vanessa, big smile. Nice. Let's go on.
Ready?
Vesna, Alex, oops. I see many screens. Okay, now I see Vesna, Jana, scream on.
Lara, one moment. You can change the design if you want.
Yes, Barbara is saying that in the chat that the panelist is not panelist, so she cannot be in the picture. That's okay. At least the panelist. Hey, Peter. Hello.
Okay, perfect. We don't have Jana and Laura image.
Maybe you can do a Photoshop.
Yeah. We will plan something, don't worry. Thank you so much to everybody. And I would like to say that you have made something huge in here, and this is the future, definitely. Thank you.
Thank you. So now we are going to finish this final conference with a video that we have done. Okay, 1 minute. I will share with you the video. We have made this video because we usually do a visit to AITIIP facilities when we prepare a conference. Due to the COVID situation, it cannot be. So we invite you to see this video of our facilities. Thank you and see you soon. Bye-bye.